the video for 6D, our objective is I will be able to analyze data using scatter plots, as well as classify scatter plots as having positive, negative, or no correlation. All right, so what is the scatter plot? This is a graph showing each pair of related data as a point on the coordinate plane. And we're going to come back and fill these in as we get to them in the notes. But they'll make more sense if we look at them in the notes and then come back and put the definition. But I like having the definition at the top of the page here so you can refer back to it pretty easily. Okay, so here is a table of phone calls that people made from a certain public phone for the years 1975 through 2000. So to make the scatter plot, we're going to label the X and Y axes. So we want to make sure that we know what these represent. So on this one, we're going to go ahead and label the X axes as years and the Y number of calls. And you see that these are 8.2. Well, it wasn't just 8.2 calls in the year. This is in thousands. So we'll put that on here too, and it says it right there. Okay, then you also want to make sure that you use a scale that shows all of your data. So what that means is if we're starting in the year 1975 and we need to get to 2000, we probably don't want to go by single years. We don't want to say 1975, 1976, 1977, 1978, 1979, because we will never get to 2000 on the graph that I've given you. So use a scale that's going to make it so you can graph all your points. So I'm going to go by fives here. So 1975, 1980, 1985, 1990, and so on. And I just stopped there just because I know I don't have any data points past there. And then on here, I want to make sure that I go up to 8. It is going to work for me to just go ahead and start 0 and just go up until I get to the end of my graph. And then you're just going to plot your data. So 1975, we're going to go up to 8.2, so maybe just a little above the line there. 1980, we're going to go up to 8. 1985, 6.5, so right there in the bottom, the middle. (1990) 4.1, 1995 3, and 2000 2.7. So we don't have a perfectly straight line, and that's totally fine. It's a scatter plot, so they're going to be scattered. All right. Based on the scatter plot, guess the number of phone, that should say calls. I'll fix it on your notes. Based on the scatter plot, guess the number of phone calls that people made from the public telephone in 1970 and in 2005. So go ahead, pause the video, write down a number, see what you come up with, and then unpause and we'll talk about it. Okay, so hopefully you came up with a couple of numbers here. So in 1970, so that would be back here, let me make it so we can see our graph. If I'm just making a guess here, and it doesn't have to be exact, it's just kind of an estimate, but I wouldn't guess anything less than 8.2, because if you look, as we go to the left, it's getting higher up. So I would even maybe say 9, so 9,000. And your answer is right as long as it wasn't below 8.2 or way out of this range. I mean, there could be an outlier, but just guessing, we would have to guess that it's probably around 9 or right around there. So 9,000 calls. So then how about in that was 1970. So 1970. So how about in 2005? Well, 2005, once again, I'm not going to guess way up here because I'm seeing that it's starting to go down as the years pass. So I would maybe guess someplace between 1 and 2. So I'm just going to say 2. Let's say that 2005, there was 2,000 phone calls. And then is there a trend? Are we seeing something happening as the years pass? Well, there is a trend. We're seeing that the number of phone calls goes down as the years go up. So less phone calls as the years increase. Okay, that's it for the front side. We don't have anything to add here, but we will be flipping back here in just a moment. So let's go to the back side of the page. Correlation. So when you can see a pattern in the scatter plot, there's a correlation between the two variables. There's a correlation between the x and y. And we have two types of correlation. We have a negative correlation, and we have a positive correlation. So let's just go ahead and write those in first. And I drew them under the graph that they go with. But if you look at this graph, it's going, generally speaking, downhill from left to right. Whereas in this graph, we're going uphill from left to right. But to put that into words, when we have a negative correlation, as the x increases, the y decreases. The y's are getting smaller. So this dot here has a small x, but a large y. This dot over here has a large x, but a smaller y. The opposite is true over here. As the x's increase, the y's increase. So small x and small y on this dot, but up here, large x and large y. Okay, so now that we have the definition of negative correlation and positive correlation, we can go back to the front here and put it so it's right at the top and you can find it right when you look at your notes. But positive correlation, as the x increases, the y increases. Negative correlation, as the x increases, the y decreases. And then what would be no correlation? Well, that would just mean there is no pattern in the points. And we'll look at a picture of that in just a moment. Correlation coefficient. So an association can be strong or weak. And the numerical calculation that measures the strength of the association is called the correlation coefficient. So these words right here, the correlation coefficient. So this number, the correlation coefficient, is always a number between -1 and 1, and is written as R equals. Okay, so if I'm going to write the correlation coefficient for the scatter plots below, I'm going to write R equals, and then it's going to be a number between -1 and 1. So a positive one is going to be a very strong correlation. You can see how all these dots here are very tightly together on a line, and it's positive, so the number is positive. And then as we move to negative, here in the middle, there's no correlation. And on the way there, it starts to get more spread out. The dots on the scatter plot are more spread out. And then as we move over to the negative, they're getting tighter again on a line. And then the negative in front just means that it's a negative correlation. So let's go ahead and try that. See if we can come up with what that is. To estimate the correlation coefficient, does the data have a positive or negative correlation? All right, so looking at, oopsies. There we go. Looking at this one over here, this data, these dots, are going downhill from left to right. So think of it like our slope. It's a negative slope. Also, as the x's get bigger, the y's are getting smaller. So we know it's going to be a negative correlation. So I'm going to put R equals, and then I can go ahead and put negative. And then if this was if all my dots were exactly in a perfect line, I might put a 1 there because it's a very strong negative correlation, but they're spaced out just a little bit. So I'm going to actually call this -0.9. Okay, so pretty strong correlation here, negative correlation, but strong one. Okay, for this one, does the data have a positive or negative correlation? Well, we're going uphill from left to right, so it is positive. And then does the data have a strong or weak correlation? Well, if you think of this as 0 and this as, a perfectly straight line, I'm going to say it's probably someplace in between those two. There's definitely is a correlation. It's definitely positive, but it's not super tight and it's not completely loose. So I'm going to say maybe it's right about here. So that would be 0.5 and positive. All right, this last one here, I don't see any correlation. The dots are kind of everywhere. As the x's increase, the y's could be anywhere. So this, when it has no correlation, has a correlation coefficient of 0. So let's flip back to the back or to the front and see what we need to add on here. So our correlation coefficient is the number that represents the strength of the correlation. All right, that is it. Thanks for watching, and I will see you in class.